Hello, mathletes. So we're gonna take a look at the Chapter 3 proofs packet. It's one that I gave you a while back, but I'll post it. I posted a link to it in the last few announcements, and I'll post another link to it when it's officially assigned. So I'm gonna go through 1, 2, and 3 in detail, and then I wanted to kind of just give you an explanation about each one briefly, so I didn't take up too much of your time in the video, and then you can just always check in and ask questions to complete the last 8. So basically the last 8 are the ones that I want you to work on your own. Some of you have already completed them and you're in class. If you got stamps on them, then you can go with that, but I would encourage you to maybe rewrite them, or at least kind of walk yourself through them mentally so that you remember how to do them and understand how to do these type of proofs if they come up on a test later on. Okay, so here we're given that, and sorry about the picture quality, so it came out when I scanned it, but we're given that line L is perpendicular with line N, and that line M is perpendicular with line N, right? So, all right, so basically N is perpendicular with both of these lines, so that tells us something, right, that we'll use here in a minute. So let me put the givens in. So, and be sure to label your or number your statements and reasons, especially if I'm checking your work. If you email me or things like that and say, hey, Mr. Glid, can you check this, or would you review this? Then it's easy to say, oh, well, on step 3, think about this, or, use this reason. So that just helps us to refer to the statements and reasons. And you can do the same, right? Mr. Glid, why'd you do that on step 5 in the video on number 3 or whatever, right? So it just helps us to reference. All right, so for statement 1, I'm going to state the givens. L is perpendicular to N, and M is perpendicular to N. All right, and then, so because N is perpendicular to 2 lines, we know those lines must be parallel, right? If 2 lines are perpendicular to the same line, they must be parallel with one another, right? So M must be parallel to L, right? Or L must be parallel to M. Okay, so I'm just going to shorthand this, but I'm going to say, instead of saying if, I'm just going to say the statement, 2 lines perpendicular to same line. Then I'll draw the arrow, so that's if this, right? Then lines are parallel. All right, to each other. That's fine. Cool. So then I'm going to put this in the diagram. So I'm going to say, okay, well, I know that L and M are parallel with one another. So that opens up a lot of things, right? Now I can, since I have this transversal here with all these numbered angles, and N is also transversal if we want to use that, but with this transversal P, I have, let's see, same side interior, I have alternate interior, I have alternate exterior, and then I also have corresponding angles, right, in a few different places. Okay, so we have a lot of options with that. Okay, so let's see. We want to prove that 3 and 6 are supplementary. Okay, and there's a few different ways we can do this. And so if you use a different way, that's great. But what I'm going to do is I want to first of all create a relationship with, since 3 and 6 are not alternate interior, alternate exterior, same side interior, nor are they corresponding, I want to try to create a relationship with 3 in an angle and then 6 in that same angle, right? So if I'm looking at these 2 angles, what angle do they have relationships with? And there's a couple options, right? I could use really 4 or 5, or 2 really for that matter, right? Or 1. So there's a lot of different options. So let me go back through those. So if I use 4, I could use same side interior and vertical pair, right? If I used 5, I could do alternate interior and linear pair. Okay, If I use 2, I could use corresponding and vertical, and not necessarily in the same order, right? You can do it in either order. And if I use 1, I could use alternate exterior and linear pair, right? So a lot of different possibilities. So use, whatever one makes most sense to you or whatever one stands out. I'm going to use, I'll use 4 just because that was the one that I think stuck out to me first. So I'm going to say angles 3 and 4 are supplementary. Okay. And the reason why is because same side interior angle theorem. And that's actually a postulate, right? And then, okay, so now that I have those, that those are supplementary, I can say, okay, well, angle 4 is congruent to angle 6. Reason being vertical angles, right? So vertical angle theorem says that vertical angles are congruent. Okay. So here's where if we have 2 angles that are supplementary to the same angle or congruent angles, we can say that they're congruent. But we don't have something that matches this. We don't have something that says if 2 angles are supplementary, or if one angle is supplementary to an angle that's congruent to another angle, then those angles must be supplementary. We don't have that theorem. Something we could definitely prove. But so since we don't have that direct theorem, we have to actually kind of work that out a little bit, right? I know this seems logical to say that, okay, well, transitive property, or, to say that they're, that angle 6 is supplementary with angle 3 at this point, but we can't use the transitive property because we don't have an equation right here, right? We have angle 3 is supplementary to angle 4, so we have to work that out, okay? So we have to say, okay, well, the measure of angle 3 plus the measure of angle 4 is equal to 180, right? And that's definition of supplementary. Definition of supplementary angles. So then once we say that, we can say, okay, well, let's work this out and say the measure of angle 4 is equal to the measure of angle 6 by definition of congruence, right? Definition of congruent angles, right? And I could have used a symbol there instead of writing out the word. All right, so what I did now is now I have equations. So now we can start using the transitive property and things like that. Okay, and so so now I'm going to say, okay, well, since these are congruent, I can substitute 6 in for 4, right? So I can say, okay, well, measure of angle 3 plus measure of angle 6 equals 180 by substitution, property of equality, right? And then now I can finally say, okay, well, that means since angle 3 and angle 6 add up to 180, they must be supplementary. So angle 3 and angle 6 are supplementary by definition of supplementary. All right. So that's how it's done. So that one, I think these steps here, you may have thought were unnecessary, but they are necessary. We just have to make sure that we explicitly use each of our, or make each of our statements and use each of our postulates, theorems, definitions precisely. Okay. And by the way, style-wise, I could have put this here right after I said supplementary. I could have put this here right after I used the congruent statement, right? So there's a few different ways I could have went about that, but those are the steps that you need.